Mastering dynamic lists in Python is vital. It is the foundation of healthy, efficient code. It is a must-have skill. Let's dive right in. Take a look at this. We have a base list containing the specific default items we require. Think of this as a standard API response. We want to return a status that reads OK, while also injecting some data into our response object. Here, we are defining user1 and setting their active status to true. Now, let's look at the response. This is where we build it dynamically. What we are doing here is defining the beginning of the response and the end of the response. In between, we want to seamlessly merge the items from these separate lists. By using the asterisk, we are performing unpacking. This is the unpacking syntax. We are extracting data from both lists simultaneously, integrating them into this final list to create our response object. This is what gets sent back through the API call. We have covered the syntax before, but this is its true real-world application. Running this, you can see how easily we capture the start, the end, and that status is OK message. Then comes the user data. User1 is an active user. Everything is delivered back in one clean, organized list. And that is all thanks to the power of list unpacking. Just remember, unpacking allows you to smart midrib multiple lists exactly where you choose. It is the ultimate way to build dynamic payloads for your applications. Understanding the difference between append and extend is vital. It's a fundamental skill for mastering Python lists. The append method is specifically designed to add one item at a time. If I want to add a report to my tasks alongside email and meetings, I simply use the append method. But what if you have multiple items to add? Let's say I need to file a report and then call my manager. That is two distinct tasks. In this case, we use the extend method to pass those new tasks rather than trying to pass them one by one. Let's run this and watch the magic. You can see my to-do list has been instantly expanded. We have email, meeting, and report. And when we run the next line, we now have the report and the call. Two new items added perfectly. With extend, you can add as many items as you want at once. It's incredibly efficient. Now, watch what happens if we try to add multiple items using append. Running this triggers an error because append expects exactly one argument, not two. This will crash your code. However, you can append multiple items by nesting them inside another list. By doing this, append sees the entire list as a single object. This creates a nested list. Check out the result. It looks like this in the output. You see the report and the manager call grouped together? Now we have two layers, the main outer list and the new inner list. While this works, it might not be the structure you need. Use the extend method if you want to keep your list flat. Or use append for nested data structures. You can even nest items with extend. Actually, you don't always need multiple items. Extending by one item works just as well. That's the beauty of Python's flexibility. You have total control over your data structure. Remember, append is for one and extend is for many. Use these tricks to build powerful, clean Python code. There are several powerful ways to insert data into a Python list. Mastering positional methods is key to controlling your data flow. Previously, we explored the append method. Remember, append always adds items to the very end of the list. While append usually adds one item, it can even nest a whole list inside another if you need it to. The extend method handles multiple items while append focuses on just one. Here, we are batch adding items like a report and a call simultaneously. But what if you need to insert an item exactly where it belongs rather than at the end? Imagine needing to finish a report before a meeting rather than after it. This is a classic logic puzzle. Let's master the precision of the insert method. We have append and extend now. Let's unlock the power of insert. Insert lets you pick the precise index for your new data point. Take task 1 as an email, followed immediately by a meeting. But wait, we need to squeeze a report right in between them. This is task 2. We'll place task 2 perfectly between our first and third items. That means targeting index 1. Remember, Python uses zero-based indexing. The first slot is 0. The second slot is 1. So we are inserting our task right here at index 1. Now, what happens to the original item? Does it just vanish into thin air? Highly unlikely. Let's see the result. Watch closely. The existing item simply shifts forward. It moves up one spot. See that? Task 2 is now perfectly nested between task 1 and task 3. Task 3 hasn't disappeared. It just shifted down the line. Can we insert something at index 0? Absolutely. Imagine a low priority job suddenly interrupted by an urgent task. This logic powers advanced schedulers, perfect for automated systems and queues. You want that priority? Just call the insert method and specify index 0. It will always jump to the front of the line. Running this, the priority job has moved everything along. That is the power of index 0. Imagine you are managing a list of users, and you need to quickly remove specific guests. In Python, the remove method makes this effortless. Here we have our users, an admin and 2 guest accounts. To delete a guest, we simply call the remove method. Now, keep in mind, remove only targets the first match it finds. Running the code shows we are left with the admin and 1 guest. The first guest was successfully deleted, but if we run the method a second time, look at that! Both guest entries are now gone. That is the core functionality of the remove method. Now, let's look at the pop method. While remove looks for a specific name or value, the pop method targets a specific position. In this case, we use the index to select our item. We are going to remove the item at position 1. Can you guess which one that is? Log 1 is at position 0. Log 2 is at position 1, and log 3 is at position 2. Python is always 0 index based. Executing this, log 1 and log 3 remain, while log 2 has been popped right out of the list. Here is the coolest part about the pop method. It actually hands you back the item it removed. Since we popped log 2, we can capture it in a variable. Now that variable is yours to use, print it out or process it however you like. You could even send that data to another part of your app. The remove method can't do that. It simply deletes the item and gives nothing back. This is a vital distinction to remember. Its return type is none, whereas pop returns the actual string that was removed. What if you don't provide an index to the pop method? If you leave it empty, Python will always remove the very last item. This behavior is incredibly useful for stacks. Think of it like an undo button. If a user navigates to page 3 and wants to go back, just use pop to instantly return them to page 2. Pop again, and they are back at page 1. It's that simple. Running this now, page 3 is gone. And if we display the list, you can see the list has been updated. One last thing, you don't have to save the popped item. If you don't need it, just discard it. We can call pop again, without using a variable or an equal sign. This simply removes the item and keeps things clean. Now we are down to just 1 page. Whether you store the value or let it go, the choice is entirely up to you. Ever needed to check if a specific item exists within your Python list? Meet the index method. Forget complex Excel formulas in Python. This is incredibly simple. It is very easy to use with the index method. You simply pass in the item you're looking for. If it is there, Python finds its exact position and stores it in your variable. This allows you to capture that location and use it later in your code. In this demo, you can see the notebook is located at position 1. Once you have that position, you can take action, like using the pop method, to remove that specific item from your list instantly. Another powerful tool is the count method. Count tells you exactly how many times an item appears. It does not give you a position, but it reveals the total frequency of an item like a yes vote. Take a look here. We have a list of yes and no votes. Let's see how many people voted yes. Running this shows 3 yes votes and only 1 no vote. If you search for something that does not exist, like yes 1, the count method simply returns 0. This is a fantastic way to validate if an item is in your list. It is a common technique when scanning error logs for your users. For example, if we want to see how many users ran into a 404 error, we just count them. And there it is. 2 users encountered that 404 error. Our count gives us that answer immediately. The great thing is that counting yes 1 still works perfectly. It safely reports that there are 0 items in the list. However, the index method is a bit more demanding. If you try to find the index of notebook 1, which does not exist, the program will crash with a value error. This error will stop your entire script from running. The best practice is to check the count first to ensure the item exists, then use the index method to find its exact location. Mastering these fundamental methods, index and count, will help you build robust programs that handle data without crashing. True expertise is built one step at a time. Keep practicing, and let's move on to the next step. Mastering the role of the comma in Python is essential for working with tuples. This concept is a cornerstone of the language. Ignore it, and your coding progress will stall. It is that critical to your success as a developer. Let's unlock the true power of the comma. At first glance, this syntax looks quite strange. Why would you place a comma after a single item? Because the comma is what actually defines the tuple. A tuple is a data structure similar to a list, but it is completely immutable. It cannot be changed. When we execute this, notice that the variable type is officially a tuple. What happens if we omit that comma? Without it, we are simply assigning a standard item. Even with these parentheses, the parentheses are not what creates the tuple. As you can see, this is just a string. Exactly. The comma is the secret ingredient here. Let's dive a little deeper. Take variable x assigned to these specific values. Notice there are no parentheses this time. What do you think is happening? What is its type? The result might surprise you. It is a tuple. It is identified as a tuple simply because of the commas. In this context, parentheses are entirely optional. However, they become vital in specific scenarios. Consider the print function. If you omit the parentheses, your output changes completely. The print method will see 3 separate arguments. Look at the difference here. In the first case, Python prints it as a single tuple. It includes the parentheses and commas, but when written like this, the print method processes them as 3 individual values, just like this. A standard print statement, accepting 3 distinct inputs. That is exactly how these values are being treated. Now, what about this example? Is this a tuple? What's the logic? Running this code reveals a pro tip. The values are assigned simultaneously to x and y. Printing them out, we get 10 and 20 respectively. This works because the right side is implicitly a tuple. This is a brilliant shortcut to assign multiple variables in one line. Technically, this is the tuple data type in action. The tuple is being assigned and unpacked into individual variables. So x receives 10 and y receives 20. Remember, the comma is the true tuple creator. Parentheses are usually optional, unless a function misinterprets your commas. If a method like print uses commas as separators, you must use parentheses to group your items together. This ensures they are treated as one unit. It's not just about the tuple itself, but how Python groups items in memory. Never forget, the comma defines your data, and this technique here, that is tuple unpacking, clean and efficient. Use this to manage multiple values with absolute precision. Enjoy mastering Python, and I'll see you next time. Have you ever wondered how tuple unpacking actually works? It is a vital concept in Python that every developer should master. Let's dive into this function. This specific function retrieves key user information. It returns a username, a score, and their current active status. You can see the return statement is sending this data back. When we run this, let's take a closer look at the definition. If you hover over the function name, you will notice that this function essentially returns a single tuple. The values it contains are string literal, an integer value, and a Boolean status. When we execute the function right here, the result we get back is clearly a tuple. We can identify it as a tuple because of these parentheses and, crucially, these commas. Those commas are the most important part. Without them, this would not be a tuple at all. Now, to extract a single item, the classic method is to specify the variable name and request index 1, which is the second item in the sequence. But there is a much better way, tuple unpacking. This is the professional approach. We define variables for the username, the score, and the status. These are new variables, distinct from those inside the function. The internal scope is protected, but here we are running the function and capturing the returned tuple, which instantly assigns every value for us. See how brilliant this is? Unpacking is incredibly efficient. It maps multiple data points to variables in one clean step. It is a powerful Python feature that you really need to master. A simple way to visualize it is like this. It's essentially doing the work manually. Imagine you set these values yourself, and they are assigned immediately. The first value goes to the username, the second is assigned to the score, and the third tracks if the user is active, and that is all there is to it. You don't even need those round parentheses. This works perfectly. If I remove this line by using the hash symbol to comment it out and then run the code, you will see that we get the exact same output. That is exactly what the function is designed for. It returns the data in a specific format, which then flows directly into this space here. The getUsername call simply retrieves those values. Once you strip away the complexity, the logic is very elegant. Everything is assigned to your variables instantly. I hope this helps you level up. Mastering this specific concept is a game changer for Python developers. Tuples are strictly read-only. They are totally immutable. They never change state. Unlike lists, which can be modified unexpectedly, tuples remain locked. This is a vital distinction. Let's look at why this protection is so important. Imagine we have a variable here. It stores our database configuration. We have the local host, port 5432, and the admin username. Crucially, we must ensure these values are never overridden. Under no circumstances should this configuration be altered during execution. When we run this, the data is exactly as intended. We want to prevent any engineer from accidentally modifying this. See what happens when they try. Here, a dev attempts to access the configuration and tries to change the IP address value. They input the change, but upon execution, the system fails. There is a type error. The tuple object does not support item assignment. This is the core strength of the tuple structure. Tuples simply cannot mutate. Understanding this logic is fundamental to writing secure code. Now, notice the result if we switch this to a list. Watch closely as we convert it to a list format. What changes? Everything changes. It looks like the same database config, but the syntax tells a different story. Previously, we used parentheses. Now, we see square brackets. Those brackets indicate that this is now a list. And look at the consequence. It's a disaster. The user just successfully changed the IP address of the production server. We now have an unauthorized server address inside our console. The entire config is corrupted. This is exactly what we want to avoid. To ensure safety and integrity in your builds, you must utilize tuples for constant data. Remember round, parentheses, and commas? The commas are the key. Even the parentheses are optional. They are primarily used for visual clarity. Observe, even without brackets, Python sees a tuple. It remains a fixed tuple. Those commas define the immutable structure. Tuples forbid any data mutation. They protect the integrity of your information. They are unchangeable. A list, however, is vulnerable. If you have critical variables like this database setup, where changes would be catastrophic, use a tuple. Define it clearly with parentheses. Always prioritize clarity by using those brackets. Choose the tuple, use the commas. Never use a list for the foundational constants of your code. If you take away only one lesson today, let it be this one. This is the most impactful rule for your workflow. Commit this to memory. Mastering this concept is exactly what separates a seasoned pro from a total beginner. It is the ultimate deciding factor in your development journey. Right here, you can see I have nested tuples within a tuple. Now, imagine a high-speed, real-time order pipeline, a core algorithm, built to process transactions the moment they arrive. Suddenly, a new order hits the system. But wait, tuples are unchangeable. This is a critical rule. If you take only one thing from this lesson, let it be this. Tuples are strictly unchangeable. They are immutable. They are locked. No matter what you do, you cannot modify them. They don't support the append method. Watch what happens when we run this code. The moment we try to add a new transaction with its unique ID and dollar amount, the entire process crashes. Tuple has no attribute append. That specific method simply does not exist here. This is where you need to think fast. As a professional developer, you know the solution is a list. A real-time system demands the flexibility to accept new data on the fly. We start with order 101 and 102, valued at 250 and 400. When order 103 comes in with a value of 150, the list allows us to seamlessly attach it to the end of our dataset. With a tuple, you're stuck. This is the game changer. Let's look at the real-world logic. You have a stream of incoming orders. Each one follows a strict schema. The order ID and the total amount. That internal structure is fixed. That part should be a tuple, but the container must be dynamic to accommodate every new sale. Your database expects that consistent ID and amount format, but your application needs to grow with your business. As we run this, notice the success. Everything is working perfectly. Now, our pipeline can loop through every ID and amount in the collection. To calculate the total revenue, we are simply summing up all the transaction values. Using our initial list, we get a value of 800. But here comes a new customer. A fresh order just landed, and we need to update our revenue instantly. By running this again, order 104 for $300 is added to the mix. When we trigger the calculation now, the total jumps to 1100 exactly as it should. While tuples might be slightly faster, they fail whenever you need to append new information. A tuple of tuples is a dead end here. The professional choice is a list of tuples. The list gives you the freedom to expand, while the tuples keep your data secure. That is the vital lesson to remember. Design your software for maximum flexibility based on the real-world scenario. The bottom line, lists are mutable. You can update them, add to them, and remove items as needed. But tuples are permanent. They don't have an append method due to their unique memory structure.